In this exercise, a 4-kilogram object is attached to a vertical rod by 2 strings, as you can see in this figure here. The object rotates in a horizontal circle at constant speed of 6 meters per second. You have to find the tension in the upper string and in the lower string. So here is your system. What we have is this is the bob, which is attached to a vertical rod by the means of 2 strings, as you can see in here. So the strings, they have the same length, which is 2 meters, and the length of the rod is equal to 3 meters. And the bob is just moving along the circular path in a horizontal circle. So it's just moving on the vertical, in the horizontal plane, sorry, and it's moving at a constant speed, which has the value of 6 meters per second. Now, what we need to determine is the tension, actually, both in the upper string and in the lower string. So since we, again, need to determine a force, we need to access this force through an equation. And the only way to do so is to apply Newton's second law. Let's actually draw the free body diagram of this object. So we have, first of all, the gravitational force. So we have mg acting on this object. Then we have the upper string, or the string in the upper, the tension in the upper string, so Tu, and then we have the tension in the lower string, which is given by this force in here. And so this would be TL. So Tu, U refers to upper string, and TL, L refers to the lower string. And that's it. So let's actually take these forces and then apply Newton's second law on these forces. But before to do so, first of all, we need to determine our coordinate system. So our coordinate system should take into account 2 axes, should be composed of 2 axes where we can project the forces on. Now, the first thing that we need to also specify in order to determine our coordinate system is the type of the motion. So in this case, we have a uniform circular motion because the bob is moving at a constant speed. Which means that we have so if V is constant, we only have one acceleration, which is the centripetal acceleration. So we know that the bob has an acceleration, and we know what is the direction of this acceleration, right? It is moving, it is actually directed towards the center of the circle along which the bob is moving. So basically, this is the direction of the acceleration. So this is AC, right? And so the best choice would be then for the coordinate system, the best choice would be to take the x-axis, which is along this centripetal direction, or along this the direction pointing towards the center of the circle. And obviously y-axis would be the axis that is perpendicular to x, and the axis along which we have the gravitational force. So this would be our y-axis. Voila. And in this case, if you apply Newton's second law, we will have one acceleration along the x-axis, which is centripetal acceleration, and another axis that, or on which we can actually we can project the forces, the gravitational force, as well as tensions. And now to do so, we still need one input, because when we want to project these forces onto x and y, we need an angle. So let's see how we can get this angle actually. What we do know, I will just draw it in here. So we do know that, so here we have, this is the bob, right? And it's connected to the rod through these 2 strings. And we have here the rod, right? So since the two strings, they are of the same length, then if you just make a perpendicular of this point towards the rod, you will end up with a perpendicular, so we'll end up with a 90-degree angle, and it will end up in the middle of the rod. Because the rod, it has a length of 3 meters, and the 2 strings, they have the same length of 2 meters. So if we define this to be our angle, let's say this is the angle theta, then we can deduce what is the angle through this triangle by saying that sine theta is equal to the opposite, which is 3 meters, divided by the hypotenuse, which is the 2 meters. And so we end up with sine theta equals 1.5. And from here, we can deduce the value of theta. So theta would be equal to, in this case, so 48.6 degrees. So theta would be equal to 48.6 degrees. And once we know theta, so this is the angle theta, now we can actually simply apply Newton's second law on the system, which is the bob, and then we will end up with two unknowns, which are TU and TL. Note that in this case, AC is known. Why? Because as we've said, the bob is moving with a constant velocity. We know that AC is equal to V squared divided by R, right? So V is known because it's just equal to a constant, and the radius of the circle also is known. So let's actually apply Newton's second law on the bob. We know that sum of external forces, or also we can denote it as F net, is equal to the mass of the bob multiplied by its acceleration. So this vector acceleration is the total acceleration. Don't forget that. What are the forces acting on it? So we have the upper, the tension in the upper string plus the lower tension, so tension in the lower string, plus the gravitational force. All of these forces, they equal MA. Now we have to make the projections onto the two axes. So let's start with the first one. Let's start with the x-axis, which we end up with. So we have plus TU, so it's just plus TU cosine, because it's in the same direction. So TU cosine theta, right? This is the projection of TU onto the x-axis, and then we have the projection of TL onto the x-axis. So we have as well plus TL cosine theta, because theta is the same up and down, is equal to, so mg has no projection onto the y-axis because it's perpendicular to it. It is equal to the mass multiplied by centripetal acceleration, which also points in the same direction. And then along the y-axis, we would end up with, so plus tu sine theta, and then minus TL sine theta, and then minus mg. All of these forces, they equal 0 for the simple reason that the bob is moving in the horizontal circle and it's not moving up or down, so there is no motion along the y-axis. So we end up with two equations and basically two unknowns, which are TU and TL. So in these equations, theta is known, AC is known, and the mass and G are known. So we end up with two equations with two unknowns, and all what we need to do is to solve this set of equations. So let's see what are the values. So here we have done it. So we end up with, when applying the numerical values, we end up with TU plus TL equals 165 Newton. And from the y equation, we end up with TU minus TL equals 52.3 Newton as well. And so we just make a simple manipulation of these equations. You just suppress one unknown from the two, so you end up with TU equals 108.6 Newton, and from the first equation you put back TU into the first equation, you end up with TL equals 56.35 Newton as well. So that's it for this problem.